Okay. Hi everyone. I'm Leslie Kanthan, and I'm from Data Spartan, and we're a consultancy, a spin-off from UCL. I also do. I have a background in mathematics, and I then went on to do a PhD to do research at University College London in graph theory with applications in machine learning. And I also have industrial experience, having worked at a number of tier 1 banks and also subsequently for the consultancy firm as well. So what I'm going to do is I'm going to walk you through some of the... I think there's a lot of you who have this experience in machine learning or in big data and are wondering where the application of this can be found in finance and what the possibilities are. So I'm going to, do an introduction and then talk to you about fintech and then regtech and then go through some topics in machine learning in finance. Nothing very quantitative, just walking through some of the projects, and then I'm going to focus on some particular projects, and if we have time, do a scenario walkthrough and any questions and answers on the slide. So, okay, so yeah. What is fintech? I don't know if you've ever come across this term before, but the official definition has it as the way in which the government, business, and academia respond to the development and commercialization of new financial business models and disruptive innovation. It's quite a mouthful, so I formed my own definition, which is creating new financial services in industry by introducing the results of recent research in academia. So essentially, what's been happening in industry is that we have academia has previously academia has different branches that are involved in industry, namely largely mathematics and computer science. And they have followed on into high-performance computing, machine learning, and big data and other paradigms. But the problem is that at the same time, what we have seen in industry is that we haven't seen that kind of expansion into the way that academia has evolved. So we've seen generally that they were still stuck in the software development cycle, still doing software engineering and applications, and there was very little innovation going on in these sectors. Then along came Google and Amazon and Microsoft, and the way these companies worked are very different, as you can see now from, you have Google DeepMind and you have Microsoft Research, and they don't necessarily work on just something to do with their company's core products, or like Office or Google search engine. They work on a variety of different things, and it's that innovation that these companies foster that lead to large amounts of profit. And so the question is, can the finance industry apply the methodologies that Google and Amazon and the likes of these firms have within their own industry to generate profit? So yeah, I mean, and that's where fintech has evolved now. So you have payments, you have money transfers, you have lending, so you've got crowdfunding and you've got funding circle, and then you've of course got the currencies, which is Bitcoin and blockchain, and then the stock markets. So we're seeing the changes now. And So what we have now is that banking is in the midst of this fundamental changes, and there's a large main shift in the disruption where you have technology coming in and new internal and external software development, and also the use of layers on top of that, like machine learning and the significant amounts of data that is being generated as well from the amounts of trade that a bank is doing, or the amounts of transaction that a retail client is doing as well. So things are changing, and in the years ahead of us, we're going to see that the way the banks do business and the way the banks look at consumers and the way that consumers look at banks is going to change. So we're going to see, I would say that the environment of the banks are going to change inside. So they're going to be more of a startup-like culture, much like we see in Shoreditch in parts of London, with many different companies that are much more smaller, bespoke, and tailored towards different client profit revenues. So we're seeing the industry catching up, and at the moment, and retail banking is going to change. So this is an overview of what fintech encompasses at the moment. And we have lending, we have personal finance, we have payments. So PayPal and Square were basically the catalysts for fintech industries. They were the two digital payment systems that helped to push us into this fintech space now. And we have retail investments, equity financing, and this is also in relation to banking and industry. So yeah, this is fintech. So now we come to RegTech from fintech, and with the emergence of fintech, there's these questions that have arisen, which is, fintech is not good or bad in itself. It's the use of technology that can be good or bad. So how do you regulate this use of technology? Because naturally, as you're applying technology in finance, there's going to be the opportunity for exploitation. There's going to be the opportunity for fraud. There's going to be a lot of problems that will come about unless there's regulation. And in some countries, actually, I don't know if that's the case here, but maybe you guys will know better, but as you have innovation in technology and you have no regulation or less regulation, there comes corruption. So it makes it very difficult for efficient work practices to be done, and it leads to higher unemployment. So, there's a lot of disruptive factors there. So what have we got here? So here we have a nice diagram here where we have the emails that we get and trade data. So assuming this is coming from an institution or some institution within the fintech industry, then we have the innovation that comes through, but we also have compliance, and compliance is the legality and regulation part, and we have the support for IT. So it's a combination of these factors. RegTech is defined here as the tech. It was coined by Deloitte consultancy, and they label it as technology that seeks to provide nimble, configurable, easy to integrate, reliable, secure, and cost-effective regulatory solutions. But I prefer to think of that it is technology that is applied for regulatory purposes. Okay, so as mentioned, we have opportunities that emerge for fraud, exploitation, scams, and deception. And there's this importance of what are governments and authorized bodies going to do about this. They have to be aware of what may happen, what can happen, what is happening. And so they have to be part of the changes, and hence they have to be part of the regulation of this industry. So this leads us to regulation technologies. So to go a bit further into this, it's not that regulation did not exist before. It has always existed, but not with the application of technology. So the classical parts are, if we look at some examples, I remember, for example, with the collapse of Lehman, with the subprime market, there was no regulation over the instruments of this type, and they were completely caught out of the blue. So one day you're going into work, and the next day you're on the floor, and everybody's being told during the internship or their job that you've lost your job. So if you want to avoid that, there has to be these kind of new practices. And so previously, firms like Lehman and Northern Rock, which is another firm that went collapsed as well, that was a bank in the UK, they relied on, well, the regulators relied on looking at their quarterly reports and auditing what they could see. But actually a lot of this is it's just a snapshot of a particular time in the company. So it's impossible to quantify all of that data without advances in technology at the time. So so regulators had to go by what was presented to them rather than be able to investigate and look deeper into the firm by use of technology. So now things have changed. So there's questions of, in regards to regulation, what protocols for this data are there, and what is the system, and who will own the regulation? Because if we're dealing with banks that have presences in multiple countries, will we be looking at that just in the UK, or will there be a European regulatory body who maintains it, and who will pay for this? So these are the questions that are continuously being asked at the moment. So the bodies themselves are quite focused on applying technology to detect these threats, and also bad players who we would consider and call as, define as people who exploit the system. So this will, lead to more data, and hence big data, and then data analytics from this. So in the future, what we're looking at, and it's already happening. So in the future, algorithms will go through transaction data in order to detect breaches and anomalies. I can tell you that actually the banks are doing this themselves as part of adhering to some regulatory bodies, like the FCA has some particular regulations in London. So this is actually taking place now, but and the auditors of the future will need programmers and big data architects to carry on with their job. And this is a fundamental fact. So previously we had accountants and we had forensic accountants. And now in a lot of firms, and I have colleagues as well, for example, in the FCA, you have big data scientists, you have machine learning specialists that are involved in basically along with accountants and forensic accountants in detecting fraud and breaches. So it's moved from just being solely, in financial professionals to financial tech professionals and financial tech and reg professionals. So, so the classical models were built making use of what today we would call small data. Yep. So this was just essentially the profit and loss accounts and some small unaudited account data, and also whatever small trade data that some of the banks had. They weren't privy to the entire trade book because that would be, between terabytes to petabytes of data, and the regulators themselves didn't know how to look into this and how they were going to investigate and see what results they could formulate from this. So now, however, things have kind of moved into this area where we've got high-frequency data, as well as low-frequency data. But largely, we have a lot of this data, and now the door has been opened for machine learning specialists who were largely, for a period of time in the theory space, to now have access to data sets that can work on this in a practical sense. So, you have access to this data. What can you see? What are the patterns you can determine from this? And what predictions can you be doing on this as well? So it's opened the door. So now we have this question, all the transactions of all the banks are put into one place, but how will this data structure look like? So this is a question that remains it's an open question, because actually the process of creating this lake of data is very slow and it's eventual. So at some point in the future, we will have an amalgamation of a lot of this data, but right now it's limited with those that are willing to contribute their data or allow it to be seen by externals. So once this occurs, there will be new techniques, both in big data and in machine learning, and how to disseminate this data and how to perform and create new algorithms on top of it. And then that will also lead to new measurements, which leads to new insights and the understanding of how this data is formed. So another thing I wanted to say is that in the UK, from where I come from, they don't have any specific big data degrees, and the degrees that I'm talking is in sense of undergraduate degrees. So at master's level, you do have a few specialist courses. You have machine learning and one or two big data master's degrees, but you don't really have something that is very much combined. And if somebody wanted to learn, or the way I learned was, apart from doing a master's in machine learning or computational stats and machine learning, the way I learned was when I went into industry, there were problems that required the use of machine learning. So you'd have to take independent courses, so you'd have to learn particular modules that you needed to know. So now the question is, so what kind of person do you need, or what does the person need to work on RegTech or FinTech related problems? And what will his academic background be? So, yeah, this is my picture. It's in the process of finishing it. So, here's the math guy, here's the computer science guy, and here's the data scientist guy. That's David there. Yeah, that's David right there. So, yeah. This is by Drew Conway, and it gives you an idea of the kind of skills that are required. So you need maths and stats, and you have some machine learning and hacking skills, and some substantive expertise as well. And this is the typical backgrounds of your average data scientist. So you can see that we're getting into becoming more and more like data scientists. So now the thing is that continuing with the RegTech, we have a significant amount of data output, and this is always growing very rapidly. So what, despite the investment, despite the flavor of the month, the flavor of the year, there's very, very little being done to effectively manage this data. So what should academia do about that? What should universities, what should students do about that? So there needs to be a body of knowledge where that means that you have a combination of computer science, politics, economics, mathematics, statistics, anything that's largely quantitative, with some of those that overlap into maybe the social sciences as well. So you need this body of knowledge so that you can address some of these open problems amongst the stakeholders, and this can be readily shared between professors, students, and industry partners, because right now what is happening is that there is this situation where you don't have a strong communication between industry partners and, for example, professors or industry partners and students in relation to all of this. So where I come from at University College London, in the computer science department, this does exist. We are successful in doing that at the moment, but that's just one university out of many, you know? So that has to change. And now I'm going to just quickly go through the banking risk. So this is one of the applications inside of RegTech, and you can see that we have 3 different areas of risk. We have credit risk, and we have market risk, and we have operational risk. And naturally, this corresponds directly with financial institutions. This corresponds with the different banking divisions. So you have the credit risk department, market risk department, operational risk department. And an example of credit risk was the default from the mortgages back in 2007. Market risk is the effect that we had by seeing the dot-com crash. And obviously, operational risk is about real losses that result from an inadequate internal process. And one example is, you know, the 9/11 terrorist attack, or, you know, the Madrid train bombings that happened here in Spain. So this is, operational risk is a primary threat for major economies of the world, and the loss effects since 2012 have mainly focused on the operational risk management and the measurement of this management as well. So these are important risk types, and they definitely require further attention amongst banks and financial institutions. So this is a field that's very closely related within RegTech. So you're seeing from the figures that, you know, there's increasing frequency and scale of such losses of events. So this is leading to a growing complexity, and this is going to have technologies in the field of big data in order to disseminate some of this. So just overview of the relationship of the big data and of risk. So what do the regulators require? They require that risk and data governance schemes address potential operational risk exposure. And that means that we're having more and more volume of data. And at the same time, we also have that you have time-sensitive processes like fraud detection and anomaly detection, from which fraud is a child of. So you can see that there's going to be an increase in this too. And then we have the various different data types that are not merged. So you have banks and insurance companies, they rely heavily on the internal and external data sources for both scenario analysis and liquidity modeling. So there is an increase in that, and then we also have some uncertainty with the quality of the data because they're coming from various different sources, and there's also physical security access and some sentiment analysis, and they contain some very valuable information. So if we're able to do some investigative insight into that, then that would lead into things. So yeah, so just generally to go through what we're going to move into now. So we're looking at fraud detection and security, compliance and regulatory reporting, risk management, and client segmentation and targeting. And this forms some of the core areas of regulation technology. And in each aspect, there is either big data or machine learning use. So it's significantly increasing. So this is just right. So now we're going to come through directly some use case examples of machine learning in finance now that we got through the definitions of RegTech and VinTech. So regarding finance, we have two kinds of actors in the industry. You have the data native and you have the non-data native. And the data native largely refers to those that are mainly tech savvy, and the non-data native would be, the banks and hedge funds that still have to do those adoptions. So the banks and financial institutions still work on legacy systems. I know this because I work for some of them, and they're very slow to adopt changes because those changes would affect their department worldwide. So adopting a change in one department would mean you'd have to adopt that change in every department across the world, all the institutions, and then across every other department that would be related to that department. So, example of a data native company, as you already know, you have Google, and it has the mindset of, let's put everything in the cloud, let's have all that data there, and let's get some machine learning specialists, and let's analyze the data that we have there in real time and, provide some results. And you have the non-data native, which I mentioned, the banks. But they need to be more like Google, and that's the aim. And I can tell you right now that there is that, at least with some financial institutions back in London, that there is that aim, and there is changes occurring now in that industry. So 80% of bank analysts have not used K-means or KNN. So the important thing here to understand is that a lot of the analysts here work with data, but they've never actually done anything with that data. So a survey was conducted in a number of these financial institutions to see what machine learning techniques, basic ones, if any, they knew. And a large proportion of them don't know anything. So if you do K-means for the banks, then you would be impressed with them so much that you're laughing all the way to the bank. So if you do fuzzy K-means, you will be head of the bank. And here's my picture. You just need to do KNN for them. You can laugh. Okay. So some of the scenario projects that have been done using machine learning are, we've got client predictive analytics. So that's an algorithm, machine learning based algorithm that's used to predict some economic type variables. So in this case, one of the client banks develops this proprietary algorithm to predict US economic variables such as US unemployment. So that was one feature. And then we have client usage analyzer, which was used to create new models and analyze events based on the usage of the data. So if you imagine that you have the trade data, but you also have this data relating to the trade data of the actual clients. So you have the clients who are conducting the trades. You have the clients who are going through many of the different web pages and the portals of the particular institution to conduct those trades. You have the client who may go into certain research reports. There are thousands of research reports released every day. So the client is a human being, right? He's not going to go through all 1,000 research reports. So knowing what his usage is, what his viewings are, what he's looking at, that is quite significant. Then we also have robust fitting techniques in operational risk loss severity estimation. So again, this is, there was a machine learning algorithm that was developed in-house. And again, all of these projects involved UCL researchers in some degree or another. So these projects were proof of concept projects, and they involved us going over there to deliver on the project so that this could facilitate in profit for the banks. So the next one is my favorite, which is the Delta One team. And that's where largely my background has been in, and that's more about developing strategies for hedging positions, and also ways of, in terms of market making, of reducing the transactional cost. So running those trades, executing those trades. So that's one area. Then you have the software development side, which is basically to create a way for not everybody in the bank is going to be a data scientist, and a very small percentage are. So, this idea that you have a lot of educated or technological based people inside of the banks, they would like to see some feasible results, meaningful analytics. They would like to see, how does my trade book look for today? What is my exposure risk? So these all lead to developing a GUI, and this is a dashboard for some of these senior heads to be able to see where the risk and the exposure is. Then you have risk scenarios IT, and this enhances both the query system in the risk IT and solutions on modeling in risk scenarios. So risk scenarios is about similar to op risk, but op risk deals with actual losses. Risk scenarios is about predicting what those losses might be, and that requires looking at historical data. And historical data goes back 20 to 30 years. So previously they would be doing some time series analysis on it, but lately we've been using machine learning and nowcast modeling to predict things 5 or 6 days from now. So that's one area. Right, so what's the typical Tier 1 institution? So Goldman, one of the banks has 2,000 traders and researchers, 45,000 supported users in 550 locations, and 10 million clients using their products. So the hardware is equally extensive, and the amount of data. So there's a lot more data, but I just kind of highlighted it to give you an idea. So you have 75,000 individual email accounts, and you have around 7.4 million emails a day, and look at the proportion of spam. So there's a significant proportion of spam, and filtering this spam is also one area of interest. And I get spam all the time, so it's obviously not working very well. And then there's, of course, the trade data, and there's the historical data. So now a lot of these institutions, they are keeping the data, whereas before they never used to keep the data. So this particular institution has data that goes back 20 years, but actually they've been, operating for around 100 years, and most of this data is recorded on paper. So one interesting problem they have is there a way where they have printouts dating back from the 60s? Is there a way of being able to read these printouts and data mine it? And the answer is yes, but because the data size is quite large, there has to be new novel techniques, because getting access to more historical data is key. So here's the proof of concept setup, the layout, and you can see that largely this part is all maintained by the financial institution. You have an apps layer, you have the software setup, platforms, and the data warehouse. It's the direction of which data is going. And here we do the computation. This part doesn't really exist at the moment in some institutions, but it's largely these three. And this is expensive, naturally, so is this. And these are legacy platforms. Software will be quite up to date because they're always updating it. They have technologists there. And then you have the data warehouse that contains all the big data volume. So what happens, for us, when we come in to do our proof of concept, we normally break it down into this kind of composition. So we're applying machine learning algorithms for prediction based on what platforms and systems that we're using and the databases that are managed. So this is an example. So we have the transaction log that we get from one of the banks, and you have all the bank data, client data, their click stream, so where they're going from one site or one part of the site to another. You have the back end or the operations part of that. That's the entire server log that's kept in the warehouse. Then you also have the external data that we might be taking in. So there might be currency exchange, social networking data, and release RNS, release news service data as well. And this all combines into data sources, and then we're modeling this, but there's problems. What are the problems? So we have integration difficulties. So we have these problems with, first of all, there might be different systems, and then we have the relationship of the data. It's not exactly, might be not specified. The data might not be clean. There's a huge amount of data. It's growing quickly by the time we're getting it to pre-process it. There's missing values and incorrect fields, misaligned data. So, as we're going through the steps of seeing that, we come to the problems that may still remain, and there's the legality. So, just to give you a point, that we had in one client, in one bank, we had access to the data of all the data that the user clicks through. So we had the entire click-through data. But there was one problem, that 15 or 20 years ago, when they recorded this data, they said on a little square box that when the client subscribed to using the services, they said that we will not use your data for any other purposes. So the problem was, we have all this data sitting in there, we were analyzing it, but we're told after analyzing it, and because the idea is to predict what the client behavior is going to be. So now we have this problem whereby the legal team is saying, well, actually you can't use the data, so how do you get around that? So we were able to get around that by looking at the server logs, but that meant data mining the server logs for the exact data that we have that's there. So, it's a very difficult issue. So again, there's legal obstacles there. So I wanted to talk through predictive analytics and what they generally encompass and what we've been doing. So here's the typical big data project. You have some research data, you have some accounting data, you have two platforms that you're getting this data from, and the data is very large, and you want to be able to run some algorithms to predict based on, you want to analyze the behavior, so you want to know based on some particular criteria what the top connected pages are. Now, I have omitted a lot of this, but I've left a scenario there so I can explain it to you, so you could replicate this if you were working on the data. But essentially, what you're trying to do, what we did was that we were looking at what pages are most useful to a user. So in terms of a workspace, you have a workspace inside of, you have a platform, and the platform is made up of workspaces. So a trader goes through different workspaces to get to the workspace and then the page that he wants to use. So my point being is that if I want to put in a long trade I want to take out a long position for an option of, let's say Santander, then I would have to go through a number of different portals and pages before I can actually place that trade. So that's actually maybe not efficient for the user. If the user knows where he wants to go, it would make sense that you would want to find what those connected pages are, top connected page, and then be able to implement that. So one way of, the overall picture of this was, could we create a dynamic system, a dynamic user interface that is distinct for each user, not one platform with one workspace and one user interface that everybody must use, but can this dynamically change? Then the answer was yes, and we had completed this project. And now the institution, from using just originally 2 machine learning and 2 big data specialists, they've now created an entire division hired a chief science officer, and they have an entire development team that comprises of 10 machine learning specialists and 20 big data specialists. And so you get the idea that once you show the proof of concept works, then they really like it. Then we have the op-risk modeling, and the idea of this was to use supervised learning to look at previous data and see what predictions could be done. Then we have the analytics. We have web analytics, which is basically looking at the correlation between popular client behaviors and certain events. So what I wanted to tell you in this is that for some institutions, so let's say there is a bank, very big bank here in Spain, and they have 10 million clients. What was noticed was that a number of those clients, the larger clients, they were followed by smaller clients in the moves that they're taking, in the moves that they're doing. So in terms of the strategies, in terms of the trading, there was almost a delay. So we had that. Then we have Delta One trading and the proprietary algos that are used on that. So that's one of the most critical areas of the bank, because not a lot of banks actually do proprietary trading themselves. They're largely market making. So one of the questions is, how can we effectively make this pricing and market making more efficient? So this is a focus on the client behavior and what is the relationship between client profitability and digital interaction and sales trading coverage. How can this be optimized for each segment? Which are the landing pages? So these are questions that can only be addressed by machine learning, and which pages do our most profitable clients spend most time reading? So this is a typical client behavior proposal. So the opportunity to increase our level of understanding of how clients interact with each institution by applying web analytics to the clickstream data. So the idea here was, again, to look at the clickstream data and see what the client was clicking through. It might be an internal client, it might be an external client, and what how his behavior could be modeled and how his behavior could be predicted in certain scenarios. So if, for example, we had this scenario where the price of crude oil had gone up, and we started to see that there was a number of clients that changed their behavior almost instantly at that point, and then a larger number, proportion of the clients started changing their behavior delayed after that. So these are one of the fundamental reviews. So again, this is the overview of the client behavior project and what was used, the tools. So machine learning, what was the specific algorithms that were used, so correlation clustering, and sequential pattern mining was used to predict between the pattern between each adjacent node. So, and then what we did in terms of cleaning the data and how the model was developed. So the models were developed within R or Python. So this is largely what's being used within banks and institutions. And then we did the result interpretation, which eventually led to a recommendation system. And the recommendation system was used for a number of different things. And one of them is we have thousands of research reports that are coming through, and what is the research report that's relevant to the user? So now there's another feature I think I'm going to. So I better not. Okay. So I think one of the most I don't have that much time. I didn't realize. I did a lot of slides, it seems. So one of the most important research areas that we covered for financial institutions was based on economic variable prediction. And I'm just going to give you a quick overview. This is the use case that we did in one of the banks. And the idea is, could we predict some types of economic variables using internal data from the bank and external data from the bank? And in this case, we were looking at the rate of unemployment. So look, I think it's very difficult. It's near impossible to predict what unemployment is going to be at. That's not what we were trying to do. What we were trying to do was predict the direction of unemployment, whether it was going to go up or whether it was going to go down, because the rate of unemployment in the US has an inverse relationship with the index. So the S&P 500 versus the initial jobless claims, you can see. So it's very closely correlated. So my point being is that if you could predict whether US unemployment was going to go up, then you would know that that would have an effect on the stock market and the positions that you're going to trade in. So how was this achieved? This was achieved, we looked at some outside database sources. So we took in Google Trends, we took in the Federal Reserve data, and we looked at the internal data that we had. So we had some internal data such as research reports that came in. We had also the trade data. We had client behavior data. So we had a lot of data, and we put those together and we tried to predict. So some of the US economic data that was used as well as secondary features was retail sales, automobile sales, initial claims, home sales, consumer confidence, because these are all related to US unemployment in one way or another. And why did we use Google Trends? Well, you know, if you've lost your job, a lot of people actually search for jobs in search engines or in places like Google, right? So if you start seeing significant number of job searches in certain parts of certain geographic areas, so say for example in Galicia, you suddenly see next month that there is 3 times more job searches, then you know something is up. So this is one of the things that we were looking at. So the question is, you know, how do you, connect these economic variables with the outside database? And the point that we were looking at as well was, sorry, I think I'm running out of time. So we took in these are some of the variable input data that we took in. We took in trade data, we took in Google Trends, we took in some transaction data, we took in the market volatility data that we had. We took on client onboarding counts. Client onboarding counts is the number of new clients that are coming to the bank after the number of clients have left the bank. So what's the net total of that? Then regulatory news service, and you can see the level of data that's coming through. So this data is in the petabyte data. This is megabyte, tetrabyte, gigabyte. So altogether, it's quite a large amount of data. This is an example of us doing the search. So we were doing the search for some keywords. We got Michigan unemployment topic, and you can see the interest over time. So this data was collected. It must be mentioned that at the time when we did this, there was no API for this. So we had to pull the data in manually. So that meant having to do the script to keep continuously doing that every other day. And these are the types of data that we had. So it gives you an understanding of what we were looking at. So we had trade data, and the trade data is something along this line, and it's very long, so it has around 500 features. This is an example. Then we have the regulatory news service data. This is an example of client onboarding and Google Trends. So this is actually real. I didn't just put this in. It was unusual, but when we were using Google Trends for unemployment, a lot of related keywords that also came up was this. So you have to filter through some of the unrelated keywords. This is real. I didn't just put Rihanna. So and then there's market volatility. So we did digital signal processing on some of the transaction in terms of their latency, so that we could see how quick the transaction was executed, and then we have the feed of the data, how it comes through, and we've got we have to update the relevance of this keyword that is picked up from the data, and we take in the data from the keyword for Google Trends, and we create a score vector. And this is our formulation. So we have the trade data, we anonymize it, remove the missing data, and we do feature selection. We add this based on the different institutions, and then we do some hierarchical clustering and filter these institutions by trades, and then look at the sell-buy ratio in consumer durables retail sector, which is an area that's related to unemployment as well. So, and here's some results. Oh, I shouldn't have put the figures there. Okay, so we did some clustering on the clients using k-means algorithm for different distances, and we did causality testing to see, the idea of the causality testing was to see which clusters affected other clusters, so we used that. And we took in market volatility, filtered the consumer confidence data, and we did the DSP on that. So there is two approaches for when we're doing the impulse response, which is the impulse response is the DSP here. So one is to do the probabilistic approach, and the other is the machine learning approach, which is better overall model selection, and the parameters estimated using functional learning, and the response of the model for the large data sets with small variance, it shows well. So here we have our impulse response function, and so we are using this to estimate what the responses are of our 5 different clusters of the clients, as we've clustered the trade data. And this is our features selection that we've taken all of these data and combined them, and then we've done our machine learning modeling on it, and we've got the end result was having US unemployment predicted up to 90% accuracy. So that meant in the end, this algorithm that was done for the bank was very effective because they were able to predict whether US unemployment was going to go up or down. And these were other potential variables, and these are other things that could be investigated and looked at. We didn't look at it at the time because we didn't have time, but they may also prove to be very valuable insights as well. And yeah, that's it. We're on time, right? Okay. Okay. So.
You were saying that banks are changing. Actually, also said yesterday that banks are changing. For the students here, so what's the kind of profile you think they are looking at? What's the blend?
Yeah, so they're looking for people with machine learning, big data experience, strong understanding in mathematics, graph theory. So when I studied graph theory, in my maths degree, it was very random. I remember my professors telling me that, it's not a very broad field at the time. A lot of people don't go into that, but I liked it. And now, graph theory is a very, very big area. It's exploded with the development of all these graphs and social networking graphs and how these structures of this graph looks like. So the answer to your question is, individuals with a good understanding of graphs and modeling and maths and stats. So that's the kind of background.
They also need engineering and they also need operations and everything. So how are banks coping now with, because that's kind of a Superman that we always describe. Is able to, how do they cope with the necessity to find all those skills in different people?
So the problem is the banks find it very difficult to find that kind of skill at the moment. But for very high level jobs, for the prediction, for example, there is, it's a small number of places, but for that they're more, they find it a bit more easier to find people, if that makes sense. Because what banks traditionally do is they look at the universities and they find the machine learning department and they try to find researchers in the machine learning department, and they say, okay, well, they're doing machine learning, so they must know what they're doing. And the problem is that there have been people who have gone from academia to go and work in financial industry, but they don't have, I would say they have the good theoretical knowledge, but putting it into practice is a very different thing. Being able to work in practice with that. So ultimately, you need people who have experienced or who have actually used live data sets in one way or another, or actually studied them in action. So it's a combination, right, of...
So you're saying there's a gap of someone putting the skill, putting something into that.
Yeah.
And here it is actually producing in theory or in art.
Yeah.
Someone has to bring this gap from bring that into art.
Yeah.
Which is an opportunity for engineers, regular engineers, to have us.
Yeah. Yeah. Any other questions? Okay.